let's begin our review for the Unit 4 test. We'll split it up in two videos that kind of makes sense for us. Okay, so the first one is to determine if each function is even, odd, or neither. Use the definition. Okay, well then we have to know the definition. It is even if f of negative x is equal to f of x. It is odd if f of negative x is equal to negative f of x. This equates to y-axis symmetry. This equates to x-axis symmetry, or to origin symmetry. Okay, so all I really have to do is find f of negative x and negative f of x, and then do the comparisons. So if I have f of x equals 3x minus 2, then f of negative x means I replace x with negative x. So that's 3 times negative x minus 2, which is negative 3x minus 2. The opposite of f of x is when I take the entire function and take its opposite, which is negative 3x plus 2 when I distribute that negative sign. Okay, so now I'm going to compare f of negative x to f of x. Okay, so this tells me 3x minus 2, I want to know if that's equal to negative 3x minus 2. They are not equal, so it is not even. Now I want to compare f of negative x, and I want to know if it's equal to the opposite of the f of x. Well, negative 3x minus 2 and negative 3x plus 2, they are not equal, so it is not odd. So it is neither. All right, if I have g of x equals negative 3 times the absolute value of 4, I'm going to find g of negative x, which is negative 3 times the absolute value of negative x plus 4, which is negative 3 times the absolute value of x plus 4. Now, if I compare these right now, if I compare g of x, I want to know if it's equal to g of negative x. The answer is yes, so it is even. It cannot be both. But I'm going to go ahead and check just in case I made a mistake somewhere. So the opposite of g of x is the opposite of negative 3 times the absolute value of x plus 4, which gives me 3 times the absolute value of x minus 4. This is not the same as g of negative x, so g of negative x is not equal to negative g of x, so it is not odd. Now you need to know the definition. We learned a shortcut about the exponents, but make sure you know how to do it with the definition. Okay, if I have y equals negative 5x to the third plus 8x, this is the same thing as saying f of x is equal to negative 5x to the third plus 8x. So if I want to find f of negative x, then it's just negative 5 times negative x to the third plus 8 times negative x, which gives me negative 5 times negative x to the third is the same thing as negative x to the third minus 8x, which is 5x to the third minus 8x. That does not equal f of x, so it is not even. Well, let's find the opposite of f of x. Well, that is the opposite of negative 5x to the third plus 8x, which gives me 5x to the third minus 8x, which is equal to f of negative x, which means that it is odd. Now, the other thing you can remember is if all the exponents are odd, then it's an odd function. Or if all the exponents are even, then it's an even function. Now, I did this one a couple of different ways. First of all, I'm going to call it g of x. I could have called it anything. Okay. All right, so if I have g of x equals x minus 2 to the third, I want to find g of negative x. So that's going to be the opposite of x minus 2 to the third. Well, that was a pretty easy substitution, but these are not the same. So this does not equal f of x, so it is not even. If I find the opposite of g of x, then that is the opposite of x minus 2 to the third. Well, that's not same thing here. You can't distribute through that. This is not, whoops, and that's a g. Not equal to g of negative x, so this means it is not odd. So it is neither. All right, process is the same here. So if I want to find, if it's to test for even, f of negative x is equal to the square root of 5 times negative x squared plus negative x, which is the square root of 5. Negative x times negative x is the same thing as x times x. That does not equal f of x, so it is not even. Let's find the opposite of f of x. Well, that's the opposite of the square root of 5x squared plus x. That is not the same as this, so that does not equal f of negative x, so it is not odd. So it's neither. Oops. Sorry about that. Okay. Let me see if I can adjust this a little bit. Okie dokie. So g of x equals 12x to the 6th minus 4x to the 4th plus 2x to the 2nd. Okay. Now, I can tell that x to the 6th to the 4th to the 2nd, these are all even exponents, so I know it's going to be even. But let's go ahead and make sure that that works. So g of negative x equals 12 times negative x to the 6th minus 4 times negative x to the 4th plus 2 times negative x to the 2nd. Well, both a negative or a positive raised to an even power are the same thing. So this is the same as 12x to the 6th minus 4x to the 4th plus 2x to the 2nd. So it is even. But just because I want to, I'm going to say, all right, well, let's try the opposite of g of x, which is the opposite of this whole thing. 12x to the 6th minus 4x to the 4th, plus 2x to the 2nd, which is negative 12x to the 6th plus 4x to the 4th minus 2x to the 2nd. This is not equal to g of negative x, so it is not odd. And again, once you've found that it's even or that you found that it's odd, then you don't have to go any further. Okay, now looking at a graph, you want to go back to the definition of on a graph. On a graph, even is when if you have an xy, then you also have negative xy. And that has to be for every point on the graph. Odd, if you have a point xy, then you also have negative x, negative y. And then neither is if you don't have that. Now, of course, also even is when you have y-axis symmetry. And odd is when you have origin symmetry. Now, y-axis symmetry means you can reflect it across the y-axis. Origin symmetry, I talk about it a little bit differently than Tori does. This is when it's a rotational symmetry. An origin symmetry is a 180-degree rotation about the origin. And y-axis is a reflection across the y-axis. Okay. All right, so if you look at G, okay, we know if you fold this up across the y-axis that they're not the same on both sides. So we know it is not even. But what we do want to look at is just look at a couple of points. And it has to apply for every point, but you can definitely find a pattern here. Let's call this point here 2, 5. Well, this point down here is negative 2, negative 5. So if xy is on the graph, negative x, negative y is on the graph. This point here, we'll call it roughly 2.60. This one is negative 2.60. Okay, and of course the opposite of 0 is 0. So let's find one that's not on there, not on an axis. So let's try this one. This is let's call this negative 3, 4. And this one is 3, negative 4. So again, a point and its opposite. Also, odd symmetry, since it's a rotation about the origin, it must go through the origin. And it does. So right here, it goes through the origin. And when I'm talking about symmetry, what that means is if I were to take this, I'm just going to put a pin in it, about the origin, and I rotated it 180 degrees, which means turn it upside down, I get back exactly what I started with. This is exactly upside down what it is right side up. So this function is odd. Okay. All right, this one clearly, if you folded it across the x-axis, it is not the same, so it is not even. And let's just pick a point. Let's pick the point. We'll call this one, just for simplicity's sake, 3, 1. If it was odd, then negative 3, negative 1 would be on the graph, and it is not on the graph. So that means it is not odd, so it is neither. Plus it doesn't go through the origin. Okay. This one, clearly, if you were to draw a line right down here and reflect it across that line, it's the same on both sides. So this is going to be even, but let's just make sure we can do it with a couple of points. All right, so let's call this the point. Let's call it 2.7, 4.5. This one is negative 2.7, 4.5. So x and y, xy is on here, and negative xy is also on here. And you can test other points. But again, clearly, this is even. They're the easiest to find. Okay. I think I'll split these up and do them one problem at a time. So we'll start another video for problem 2.